adding and subtracting functions is the same as adding and subtracting polynomials. Which we did at the beginning of chapter 4 prior to our final exam first semester. So it used to be in chapter 4, I would give you parentheses, polynomial, plus parentheses, polynomial. You'd have to add your polynomials. Now the notation is a little bit different. They are going to say f of x plus g of x, or f of x minus g of x. So here they want us to do our f function plus our g function. Our f function is x squared minus 5x plus 8. And our g function is x squared minus 4. When you're adding, you're combining like terms. So x squared plus x squared is 2x squared. Negative 5x, there's no like term, so negative 5x. And 8 plus negative 4 is positive 4. F of x plus g of x is 2x squared minus 5x plus 4. That's it. That's it. Okay? Now, because we have now learned about radical expressions, rational exponent expressions, they are going to throw some of those into the mix. So that's where it might get a little confusing. So here our f function is x raised to the 1/3. Our g function is 3x to the 1/3. And we are adding f and g. When you're adding, notice in number 1, x squared plus x squared is 2x squared. You're not actually changing the exponent, you're just combining like terms. So here we have 3x to the 1/3, and here's another x to the 1/3. So how many x to the 1/3 do we have total? 4x to the 1/3. Number 3, this time we are subtracting. So we have our f function, 3x squared plus 4x minus 6. We are subtracting our g function, 2x minus 6. Now, why in the world did I write this one with parentheses? Because when we subtract, you have to subtract all of that g function. So you have to subtract the 2x. You also have to subtract the negative 6. So it's kind of like you have to distribute that negative. So this is going to be 3x squared plus 4x minus 6 minus 2x plus 6. You have to subtract the 2x. You also have to subtract the negative 6, which is adding 6. Now combine our like terms. We've got 3x squared. 4x minus 2x is 2x, and the negative 6 and the positive 6 cancel each other out. Multiplying functions is the same as multiplying polynomials. Now notice, this is asking us to find f of x times g of x. Do you see an equal sign anywhere in that? No. F of x times g of x, it doesn't say equals something, it's just find f of x times g of x. Find the expression. We're not solving any equations, we're not doing anything crazy like that, we're just combining the functions using multiplication and then simplifying that expression. So, our first function, f of x, is 5x plus 6. And we are multiplying that by our g function, 4. How do we multiply 5x plus 6 and 4? We distribute. So 4 times 5x is 20x. 4 times 6 is 24. Number 5. our f function, 2x plus 3, multiplied by our g function, x minus 4. This time we need to double distribute, combine like terms, all that good stuff. Not factor, just multiply these together. Double distribute, FOIL, whatever you want to call it. So take a minute and do number 5. When we double distribute, we get 2x squared minus 8x plus 3x minus 12. That's just double distributing. So our answer is 2x squared minus 5x minus 12. Number 6. Our f function is 3x to the 2/3. Our g function is negative 5x to the 1/3. What I want you to realize in this problem is that 3x to the 2/3 is not 3x to the 2/3. It is 3 times x to the 2/3, and this is negative 5 times x to the 1/3. And with multiplication, the order that you multiply doesn't matter. So we can move this around. So we have 3 times negative 5 times x to the 2/3 times x to the 1/3. So 3 times negative 5, that's the easy part. What is 3 times negative 5? Negative 15. For the x's, if we are multiplying with the same base, both of them have a base of x, what do we do with those exponents? You add them, and 2/3 plus 1/3 is 3/3, which is 1. So we just have x to the 1. If you need to put a note up here, we did x to the 2/3 plus 1/3, which is x to the 3/3, which is simply x. Dividing functions is the same as dividing polynomials, except we aren't going to do long division or synthetic division or anything like that. We're basically going to put the f function over the g function. If it is polynomials, we really aren't going to be able to do a whole lot of simplifying. If it's an exponential expression, we may be able to do some simplifying now that we know those exponential rules. So our first example, number 7. We're doing f of x divided by g of x. So 3x minus 6 is our f of x function, divided by 2x, our g of x function. There's really no simplifying that can be done there. Our answer is 3x minus 6 over 2x. Now, I am going to say, what if it had been 4x minus 6 over 2x? Look at the whole number pieces. 4, 6, and 2. 4, 6, and 2 all have a common factor of 2. So you could cancel out a common factor of 2 and make this 2x minus 3 over x. So if all of the whole number pieces are even, or they're all multiples of 3, or whatever, if there's a common factor, you can cancel that out. Now, up above, I wrote in, think about domain restrictions. Domain refers to the x values of a function. In math, there's one big, huge, massive rule involving division. Does anyone know what that rule is in math? You cannot divide by 0. So when we divide functions, we need to think about, are there any potential x values that would force us to be dividing by 0, and we have to exclude those x values. So think about this denominator, 2x. What x value times 2 would give you 0? 0. 0 times 2 is 0. So in here, we need to write in a domain restriction saying x cannot equal 0. So our answer for number 7 is 3x minus 6 over 2x. X cannot equal 0. Dividing by 0 is like opening up a black hole that's going to swallow all of us. It can't be done. So you need to make sure you think about, what would make my denominator equal to 0? Hey, x can't be that. f of x is fine, g of x is fine. You could plug 0 into either of those, but the instant that you create a new function by dividing these two, then you have to think about, hey, by the way, people, you cannot use 0 in this new function. Number 8, we need to look carefully at how this is written. Our f of x is in parentheses, 3x to the 1/3. Our g of x is not in parentheses, 4x to the 1/4. So on the top, 3x in parentheses raised to the 1/3 means 3 to the 1/3 times x to the 1/3. And on the bottom, we have 4 times x to the 1/4. Okay, now think about if you're dividing with the same base. What do you do with the exponents when you're dividing? You subtract them. So in your calculators, beep, boop, beep, 1/3 minus 1/4. What is 1/3 minus 1/4? 1/12. So this is 3 raised to the 1/3 times x raised to the 1/12 over 4. So x to the 1/3 over x to the 1/4 became x to the 1/12. All right, domain restrictions. In the denominator, we have 4. Is there any way, if we plug any x value in, is there any way that we're going to make 4 turn into 0? No. So we don't have any domain restrictions due to the denominator. Do you see something? Okay. But think about x to the 1/12. An exponent of 1/12 is the same as a 12th root. X to the 1/12 is the same as the 12th root of x. That is an even root. Can you plug negative numbers into an even root function? No. So our domain restriction would be x is greater than or equal to 0. This means positive numbers only. You can only put positive numbers into this function because you can only do the 12th root of positive numbers. And that domain restriction is not nearly as picky as the denominator domain restrictions, but it's still something that we need to think about, and it's something that we're going to have to think about tomorrow, so let's just start thinking about it now.